Bismillahirrahmanirrahim. So we're going to continue with chapter 11 algebra 1, and we're going to talk about radical functions. Okay, so when you have something like this, okay, 2x, y, this is a radical expression, right? We got that. And then we have something like this, square root of x minus 2 equals 3. This is a radical equation. And then when you have y equals 3 times square root of x plus 2, this is a radical function. Correct? So we have that. So today, inshallah, we shall talk about radical functions. So radical functions are like this: y equals square root of x. This, in fact, y equals square root of x, this is the parent radical function. Now if you recall, y equals x squared, okay, this was a quadratic function, and quadratic functions were parabolas. So that was the parent quadratic function. When we say something is a parent function, we mean that it is a representative of that class of function. So this is a parent function for radical functions. So in other words, if you understand this function, you understand a whole host of radical functions, a whole category of functions, equations that have that are similar to this. So this is a parent function for this class of functions. So if you understand this, you understand a great deal about radical functions. So the first thing we have to understand, okay, what does this look like? Okay, what is the graph of this look like? So before we did this, for example, y equals x x squared, and that was a parabola, right? So that was the parent function, and then that was the parabola. And the question now is, what does this look like, right? So let's try to graph this, okay? So let's try to graph this. Let's do it the old-fashioned way. Let's make a table over here. So x and y. So I'm going to pick some values. 0, put here. 1, 2, 3. I'm still doing 1, 2, 3. I'm going to pick some strategic values, okay? And I'm going to pick 1, I'm going to give 4, I'm going to pick 9. Okay, just humor me to make the math easy. I'm going to pick -1, -4, and -9. Okay, so when x is 0, what's the value of y? Well, you just substitute 0 over there. You get y equals square root of 0, and that's what? 0. So when x is 0, y is 0. That's easy enough. Okay, when x is 1, what's y? Y is square root of 1, and that is 1. So when x is 1, y is 1. So when x is 4, you substitute 4 over there. Y equals square root of 4, and that is 2. And then when you put 9 over here, y equals square root of 9, then that's 3. And then you go over here. Let me just put the 3 over here. And then you go over here, -1. So y is square root of -1. Oh, that's the problem. Because you can't take a square root of a negative number, see? Right? So y equals square root of -1, y is square root of -4, y is square root of -9. These don't work. You can't take a square root of a negative number. In other words, this graph, there's no negative values over here, okay? For x that works. You might as well erase this part of the graph, see, like this, because you can't put a negative number in that equation. In other words, that's not part of the domain of this function. So x cannot be a negative number, okay? So let's graph the numbers that we know. When x is 0, y is 0. Okay, we got that, right? When x is 1, y is 1. Okay, we got that. When x is 4, 2, 3, 4, y is 2. And then I have to go all the way up to 9 over here. When x is 9, y is 3 over here. Now if you were to plot all of these over here, and you would get a function, okay, that looks like this. I'm kind of like doing an artistic version of it, you know. Comes back. Okay, so that's how this looks. So this is the graph of y equals square root of x. So this is the parent function graph. You gotta know this. Okay, so the graph of y equals square root of x looks like this. Okay, so this is very important to understand. Okay, it's kind of funny looking graph because there's no values over here. So in other words, you can't put in negative numbers in this equation, right? So the domain of this function, domain is all possible x values, is restricted, right? X can be 0, x can be 1, x can be 2, x can be 3, x can be 4, x can be any positive number, x can even be 0, but x can't be any negative number. So the domain is restricted. X has to be greater than or equal to 0, right? So domain is restricted. This is extremely important thing to understand. For this particular function, the domain is restricted. It's not all real numbers. And the range, which is all possible y values, is similarly restricted. Y is never going to be a negative number because the graph is going like positive over there, right? So y could be 0, y could be 1, y could be any of these numbers, but it can never be negative, right? So similarly, y is restricted. Y is greater than or equal to 0. So a couple of things we have to understand about this parent function is how it looks. And then we have to understand the domain and the range are both restricted for this function. Okay, now look. So we have y equals square root of x. The parent function of this graph, okay, it looks like this. It's kind of easy to remember because it kind of looks like a radical symbol, doesn't it? It's like woohoo, like that. So the parent function of a radical function looks like a radical symbol like this. That you have to know. The other very important thing about this radical function is that the domain and the range are restricted. So the domain, which means all the possible x values, has to be greater than or equal to 0, and the range, which is all the possible y values, has to be greater than or equal to 0 as well. Okay, so this graph is restricted at this quadrant, the first quadrant of the Cartesian plane, right? So domain and range are restricted. So let's draw this parent function out here. Okay. Now, if you see this function on the side here, this is a quadratic function. You should know that. You should know that this is called a quadratic function. Quadratic functions are parabolas. I mean, it's just like knowing like people's names, you know. Okay, let's draw this. See, here's the parent radical function. It looks like this. All right. In fact, it's like half of a parabola, really. Okay, it's half of a parabola. But you don't call it half of a parabola, you could just call it a radical function. Okay, so it's very important. And this, let me zoom out over here. See, it's always restricted. I mean, it's only in the first quadrant. Okay, so now we know. Now that we know that this is the parent equation, okay, that's the parent function, we can learn a few more things about it. So if this function, okay, let me draw this out, the parent function. If the parent function looks like this, okay, that's y equals square root of x. Now what does this look like? Y equals negative square root of x. Okay, well, if you remember, y equals x squared, that was a parabola that looked like this. Okay, and I asked you the same question, what does y equals negative x squared looks like? Well, then it was like the mirror image of this, like this, right? The same thing here, because for every x values, this function is just going to minus it. So for this value, if the x value is this, it's going to minus that to bring it down here. So it's going to be a mirror image of this function across the x-axis. Okay, so this function is going to look like the mirror image of that function, like this. Okay, so this is y equals negative square root of x. Okay, so let me draw this out for you. So y equals negative square root of x. See, the blue, that's the reflection of this function over x-axis. Now between the two of these functions, they kind of make a parabola, don't they? That's true, they do make a parabola in fact. And these two are, this shape of this figure is a parabola. So radical function like half of a parabola, if you can like think about it. You understand? Okay. So now look. So I told you if I give you this, that looks like that, and this looks like the mirror image of this, correct? How about this one? If I give you, if that's the parent equation, okay? If that's the parent equation, compared to the parent equation, what does this look like? 3 square root of x. If that's the parent equation, what does this look like? Well, would you rather be paid this or would you rather be paid this? Assuming that you wanted to make money so you can, you know, do some good work with that. Well, you rather be paid this because this is more pay. It'll go up faster for any given amount of x's, right? For any given number of hours you work, you get more paid. So this function is going to go up faster. It's going to be like this. Okay? It's going to go up faster like that. So that's y equals 3 square root of x. So, right? So let me draw that for you. So let me get rid of this. And I'm going to put lots. I'm going to put a 3 over here. See? See, it's going to go up faster. So the red graph is the parent function. The blue graph here is the y equals 3 square root of x. If I put, okay, I'm going to put 13 square root of x. It's going to go even much faster, right? But still, they're radical functions, right? Right? So, I'm zooming in again. So let me go to back to 3, okay? So that's that. Now, I got that. Now, how about this? Okay, y equals 1/2 square root. How's that going to look? Well, that's going to go up faster. This is going to go slower. It's going to be like this, right? So that function is going to look like, let me just do that one, okay? So that's y equals 0.5, which is half, square root of x. See, that's the green function. It's going to go slower. Okay? So, what did we learn so far? We learned so far, all of this is what we have learned. That if you know the parent equation, that you can deduce from it how you can tell basically how this is going to look. That's going to be the mirror image, right? And you can tell that this is going to go up faster, right? And you can tell that this is going to go up slower, right? Right? Now how about this one? How about y equals square root of x plus 3? Okay? Now, I just want you to notice something. This is similar to this. Here is y equals 3 times square root of x. Okay? This is y equals square root of x plus 3. Okay, how does that different? Well, this function, the yellow one, was just going up faster, like this. It goes up faster. But this function here, see, this one, see, it's going to be moved up 3 units. If this one's like here, it's going to be like 1, 2, 3. Right? It's going to be like this. It's going to be this very graph, it's the parent graph, is just going to be moved up by 3 units. It doesn't go like this. This graph and this graph, they start at the same starting point. This graph is the parent graph moved up 3 units. You understand? So let's see. So that's the original function. Okay? So this is y is square root of x. This is y equals 3 square root of x. And let's compare that to y equals square root of x plus 3. See? See the green function, the red function, right? This is a parent function. And if you just move the whole thing up by 3, you get that. Compare that to this one, right? They're very different, right, in behavior. Okay? So now look what we have learned, okay? So if you know the parent function y equals square root of x, then you can say, I know how this is going to look like. Then you can say, I know how this is going to look like. Then you can say, I know how this is going to look like. And then you can say, I know how this is going to look like. Okay? So these are all things that if you understand this function, you can kind of get an idea of how all these functions are going to look. Then, after knowing this, then we can write the general equation for a parent for all radical functions. So this is the parent function, y equals square root of x. Okay? The general equation for all radical functions is, okay, y equals a times square root of x minus vx, okay, plus vy. I have to explain to you what that is. Okay. Now, if you recall from quadratic function, the parent function was this. And the general equations was y equals a times x minus vx squared plus vy. And if you notice, these are very similar. This is a, x minus vx, and vy. A, x minus vx, vy. The only difference between these two is this one has a square and this one has a radical symbol in the same area. Okay? So I'm going to explain this to you. So if you have a radical function like this, okay, the general, it looks like this, right? It starts from the origin like here, like this. This is the parent equation. Okay. Now this is the origin. This is the beginning of the radical function. I call this the pseudo-vertex. Pseudo meaning like fake, right? Pseudo-vertex. This is my own affectionate terminology. Okay. Right? So that's I call it the pseudo-vertex in quotes v. It's not the vertex, but it's like pseudo. And I give it the same vx and vy. So this ordered pair, I call it vx and vy. Okay? Do you understand? So that's vx and vy. Once you understand this, see, then you can see this function is very analogous to a quadratic function. This is a times x minus vx squared plus vy. That's a quadratic function, all right? Whereas a radical function is y equals a times the square root of x minus vx, okay, plus vy. Now notice the only difference is this is replaced with this, and the square here is the defining feature of this quadratic function, and this square root sign is the defining feature of a radical function. So it makes sense that the only difference between the two is just that. Everything else is the same. In other words, I could take my little eraser, erase that 2, alright, and then replace that with the radical symbol, and I got a radical function. Okay, they are very similar. That's why I use the same terminology, because it makes it so much easier to remember the two. Many books use for vx and vy, okay, they use h and k, and that's good too. Right? There's nothing wrong with it. You can call it, I don't know, MN if you wanted to, right? You can call it anything you want. It's a free country, right? Still, you know what I'm saying? So, but I use Vx and Y because it's consistent. Do you understand? It's not like the vertex, so like it is for this function. But this is the general equation of a radical function right here, okay? And you really have to know both of these. Now you should write this down like 5 times or something like that, at least until you feel comfortable with those. These should be memorized. You should know that. So if somebody randomly stops in the street, hey, can you tell me what the general equation for a radical function is? Sure, you spit it out like as if you knew it for like 100 years or something like that. So that should be like old hash. You know that really good. But how do we graph some of these? So let's just take some examples, okay? So here's a radical function. This is square root of x minus 2 plus 3. Okay, so I'm going to graph this, okay? So here's my Cartesian plane, the coordinate plane. I'm going to try to be a good boy here and try to label my axes, and I'm going to try to label a few points. It's 2 and 3, 4. This is just mathematical good manners. So now I don't set a good example for you sufficiently, so I think in this way. So this time I'm going to do it, and then just to label a few points, like this and like that. Okay, I'm good. Now I feel better about it. So now you have to remember the general equation is y equals a times the square root of x minus vx plus vy, right? So maybe I could do a better job writing it a little neater. Okay, that's better. Alright, now in this case, what's a? A is 1. Okay, now that's very important because y equals square root of x in the parent equation. What's the a? A was 1. When a is a positive number, the graph is going to look like this. Okay, and when a is a negative number, the graph is going to look like that. It's going to reflect this. It's like this, y equals negative square root of x, right? So a is very important because it kind of tells you which way it's going. Is it going up ways or down ways, you know? So in this case, a is 1. It's very important to understand that. Then what's the pseudo-vertex, so to speak? So what's the pseudo-vertex, which is the vx and vy? You should do yourself a favor when you're graphing this. Just be methodical about it and be systematic about it. Write things down, make it neat, make it look pretty, you know. That way you don't make silly mistakes, because you don't want to, you know, as I always say, it's more important to get the question right than to look cool, right? So just do it methodically, write down the 2 and 3, so you don't do something like -2 or 3 or something like that. Okay, it's 2 and 3. It's not -2 because there's a negative sign. You understand? So that's the pseudo vertex, so to speak. That's 2, 1, 2, 3. Okay, you can call it HK or VX, So I'm just going to label that. I'm going to be a good boy. I'm going to label that 2, 3. So what this means is, so for the parent function, see, it was like this. Now this vertex is going to be moved to, and it's going to be moved over here. So it's going to go this way and goes this way. So that's going to be like the new vertex, okay? So, and then see, I'm going to draw the new here. I'm going to draw the new x and y axis like this, okay? So the vertex, which used to be over here, is going to be moved 2 units this way and going to be moved 3 units up that way, okay? So that's going to be like my new vertex right there. Ta-da. And then the graph is going to look like, okay, now look at this. Y equals square root of x minus 2 plus 3. Then the second thing you have to, is going to look like this, or is it going to look like that? Well, it's going to look like this, right? Because a is 1, correct? So, okay, I know it's going to look something like this, okay? Okay, so that's good. So now, okay, so now I'm going to need some more points, like over here. I have to pick some points out, okay? So what am I going to do? Well, I have the rule, I have the function given to me, for God's sake, so I can just put make a small table and get some more values, so x and y. Now, I'm not going to pick 0, because the function doesn't exist there. The function is only like this. There's the domain and range of these radical functions is restricted. I mean, there's no graph over here. The graph starts over there and goes over there, right? So if you put in 0 in the equation, it's not going to work, right? Because let's do that. So y equals square root of 0 minus 2 plus 3. That's the square root of negative 2 plus 3. And that's like haram. You can't take a square root of a negative number. That's wrong, right? So 0 doesn't work, 1 doesn't work, 1.5 doesn't work, 2 works, but that's the pseudo-vertex. Do you understand? So the domain and the range is restricted for these functions. So you have to understand the only values of x and y that will work will be starting from here and going this way. Okay? So the only x values that will work are going starting from here and going that way. Okay? All of this from here, okay, that does not exist for this function. If you plug any of those x values into this equation, you'll get a negative number under the radical, and that's like a no-no. That's like a big no-no, alright? You understand? So the domain is restricted over here. Okay. In fact, the domain is restricted to what? So the domain, all the x values have to be at least 2, right? The x has to be greater than or equal to 2. And the range values, which is all the possible y values, okay? Can y be 0? No. How is it going to be 0? Because it's going to start over here and go up, right? So it's going to be 3 and above. So the y value has to be at least greater than or equal to 3. Does that make sense? Okay, so the domain and range. You should be able to write this. I mean, well, come on, it's not like rocket science here, okay? This is the parent equation. The graph is only over here, right? The domain is going to be this, and range is going to be that. Now here it's going to be moved this way, it's going to be moved that way, right? So just, x is going to be bigger than this, and y is going to be bigger than that. I mean, that's the only way, right? Maybe it is rocket science, actually. Maybe there is some of this in rocket science. I don't know. I'm not a rocket scientist. What do I know? Okay, anyway, so that's that. So you should be able to write domain and range, okay? Alright. So, okay, well, if I So I need some values. I can pick, let's pick 3. I can pick 3 over here. So what's y when x is 3? Easy enough. I substitute 3 for x, so it's a 3 minus 2. Okay, plus 3. That's square root of 1 plus 3. Square root of 1 is 1 plus 3 is 4. Okay, I got my one more value over here. Okay, let's pick another value. I could pick 4. If I put 4 in there, 4 minus 2 is 2. Square root of 2 plus 3 is 9. Nice number, right? What will give you a nice number under the radical? How about 6? If we put 6 in there, 6 minus 2 is 4, right? Okay, let's put 6 in there. So 6 minus 2 plus 3. 6 minus 2 is 4. Okay, that's 2 plus 3 is 5. Okay, I got my, so 6 will give you 5, right? So now I got my points. So I go over here. So I put 3 over here, and I get 4 right there, right? And I put 6 over here, and I get 5 over there, right? So here's my graph, right? Now I just want you to appreciate a couple of things over here, right? What did I do? What did I do? Well, I think I had just mathematical manners, so to speak. First, I labeled my axes. I was a good boy, and I labeled some of these points over here. Usually, if I do that, I like to label 2 at a time because it doesn't look as cluttered. Like I didn't go 1, 2, 3, 4, 5, 6. I went 2, 4, 6 because it's not as cluttered. Okay. And then what's the first thing I did? I got the vertex, the pseudo vertex. I put it in there. And after I got the pseudo vertex, I didn't stop. I made like the new, kind of like this, the new x and y axis, so to speak, over here, like that, right? And then I got 2 additional points to complete the graph. Okay, so that's how you graph radical functions like this. Does that make sense? And I know the domain, I know the range. All right. So let me graph this over here. So there was a square root of x minus 2 plus 3. Now look at this. Okay. This is the parent function, and that's this function. Okay, so this blue function is actually the parent function moved up, moved horizontally by 2 units and moved vertically by 3 units. So there's a horizontal shift to the right by 2 units and a vertical shift to the right by 3 units. Okay, they're the same graphs otherwise. Okay, so if I were to draw like this, x is equal to 2 and y is equal to 3. Okay, that's like the new x and y axis, see? Okay, and that's the new, do you understand that? That's the new pseudo vertex right there. Okay, so that's how that graph. Now look, now if this over here, look at the blue graph, that's the graph. If this over here was a -1, well, how would that graph look? It would be the same graph, just flipped over one, right? So let's do that, -1, see? The same graph flipped over one. Okay, well, let me put it back the right way. Okay, what if I put a 3 there? It would just be blue graph going up faster. Watch this. You see this? Do you understand that? So the shift will tell you this, and then that will tell you how this number will tell you how it will look. Okay. So let me do just one example. Y equals -1/2 square root of x plus 1 and plus 3 plus 2. I'll make it kind of like that. Whew, that looks tough, kind of, huh? Well, no, let's do progressive logic reason, right? Right? So watch. This is the general equation. A times square root of x minus vx plus vy, right? So that's the general equation. Oh, well, let's do it. I mean, everything is tough until you try it and just see what happens. Okay, let's do this. So we got this. So let's just like before. What's the pseudo vertex here? Okay, well, what is it? Well, it's this, right? So it's going to be, oh, it's -1 here. Be careful, right? It's negative sign over here. So it's -1 and 2. So that's the pseudo, right? So it's -1 and up 2 over here. So that's -1. So -1 and up 2. That's the pseudo. Now, as soon as I got that, I can just kind of draw like the new x and y axis, so to speak. okay? So like this, okay? Because that's going to help me draw. So we got this, okay? So far so good. Okay, now what do we do? Okay, now and this is -1, this is -2, that's 2, that's 4, that's 2, that's 4, that's -2. Okay, so we got that. Try to set a good example. Okay, now look. So now we need some more points, right? Now look at this over here. That tells me the graph is going to look like this, right? So this graph is going to look something like this, okay? Because A is negative. Okay, so that I know, okay? So I need some points, okay? So I need some X points and Y. Now look at this. Now even from this we can figure out what the domain and the range is going to be, okay? So domain and the range is going to be restricted. So the domain is going to be all the possible X values. They have to start from here. X can't be over there because the graph is going for this way, for God's sake, right? It's not going to be over there. So the domain is going to be X is greater than or equal to -1, right? And the graph is going like this. So the range, all the possible Y values, they're going to start over there and go down, right? So they're going to start over here and go down. So the Y values are going to be less than or equal to what? 2. They're going to be from here and going down, right? They're not going to be going up. In this case, they're going to be less than or equal to 2. Does that make sense? Okay, so I need some more points. Well, in this case, I can pick 0, right? Because I know it's going to go this way. So when X is 0, what's the value of Y? So here it is. Y equals -1/2. So 0 plus 1 plus 2. That's -1/2. 0 plus 1 is 1 plus 2. That's 1, so this is -1/2 plus 2. This is 1.5, 1.5. So when X is 0, it's like over here, okay? Alright, when X is 3, so it's like 1.5. I'm going to put 3 over here. If you put 3, because I know if you put 3, like 3 plus 1 is 4. That's 2, right? So when X is 3, you get -1/2 square root of 4 plus 2. This is -1/2 times 2 plus 2. This is -1, so it's 1. So it's 3, it's going to be like over here. So the graph is going to look like this. Okay? Follow? So let's do that. Let's graph this one. We don't need the parent anymore, so I'm going to just do it here. It is -0.5, and then I said -1, did I say? I said +1 plus 2. There it is. Right? So it's like that. Do you understand? So plus 2. So that function starts right here. Look at this, okay? Let me zoom in a little bit here. Trying to get that point, capture that point. Okay, well, let me do it. Come on now, could be here. -1, 2. So that's the sort of vertex, right? So it's not so. So if you do it methodically, you don't panic. It's not too bad. So here's the general equation of a radical function. Okay, so x minus v x plus vy is very similar to the quadratic function. Okay. Now, last thing I want to do is this. Okay, now watch. What if I gave you a quadratic function, a radical function, okay? 1, 2, 3, 1, 2 here. And it goes like this over here, okay? And I tell you this is 3 and that's that. And then, alright, I'm just making this up. So this point is on the graph. 5, I don't know, 4, okay? Now, I'm asking you, okay, I want the equation of this function. How do I do it? Well, it's pretty tough, huh? Well, what's the starting point? All the equations for these are going to look like this, right? They're all going to have this form, okay? Because we know that form. Well, what do I know so far? I know the vertex that's given to me, the pseudo-vertex. That's 3 and 2. Well, that's very good. I know this already, so I can plug that in, right? That's easy now. So I got y equals a times square root of x minus 3 plus 2. Okay, that's very good. The only thing I don't know is a. Well, maybe this is all I can do. No, this is all I would have been able to do unless I was given another point. Okay, if you were not given this point, you're stuck. That's all you could do. You never know what a is, and good luck. Okay, but we know another point. See, so what we can do then is we can take this point and substitute that in the equation for x and y. Okay, substitute this in place of x and y, and then solve for a. Okay, so I do that. So let's substitute that. Y is 4, and that's a, and x is 5 minus 3. Okay, plus 2. Okay, so I get, okay, so and then subtract 2 from both sides, right? Okay, so let me do it slowly. So 4 equals a times square root of, that's 2, plus 2. Okay, then subtract 2 from both sides. I get 2 equals a times square root of 2. Now I have to solve for a now. How am I going to do that? Well, I have to divide both sides by square root of 2. Like this. Okay, then a is 2 divided by square root of 2. That's not so bad. Well, you know, since we're such good students, we know that it's not good mathematical matters to have radicals in the denominator. So we're going to rationalize the denominator. That's called rationalizing denominator, okay? So we multiply top by square root of 2. On the top you get 2 times square root of 2, and the denominator 2 times 10, that's just 2, right? Now while these cancel out, that becomes square root of 2. Oh, that's not bad. Now we know what a is. So this then becomes this. Y equals, a is square root of 2, square root of x minus 3 plus 2. You can leave it like that, and that's perfectly alright. Like this. Okay? Ta-da! So you can figure out the equation of the radical function if you're given the vertex and this reasonably easily in this manner that I've shown. So inshallah, hope that helps. You got to know that this is the general equation of the radical function. You have to be able to graph them. You have to understand the parent equation really well, and you also appreciate how very similar these are, at least in their general form compared to quadratic functions, etc. So inshallah, until next time then, salatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.